Hello, everybody. Today we are here with Luna the Math Cat, and we're going to study special angles on parallel lines, right, Luna? Okay, so a line that intersects two or more other lines is called a transversal. So here I have two lines, line L and line M, and this line crossing them, line T, is called a transversal. Okay, so most of the time we talk about transversals, these two lines, L and M, are parallel, and they are in this case. You can see because they got the parallel line marks on there, and it forms 8 angles. 1, 2, 3, 4 on the top, 5, 6, 7, 8 on the bottom. Okay, a transversal creates 3 different kinds of special angles. The first are called alternate interior angles. Okay, so alternate means they're on different sides of the transversal, and interior means they're between the two lines. So alternate interior angles would be angle 5 and angle 4 would be one example, and the other example would be angle 6 and angle 3. Okay, those are alternate interior angles. Okay, there's 2 pairs. We've got them right here. Okay, so alternate interior angles. Now, another type is alternate exterior angles, which are pretty much the same thing, except they are outside the lines. So one example would be angle 2 and angle 7, and the other would be angle 8 and angle 1. Okay, so those are alternate exterior angles. Now, corresponding angles are angles that are in the same position relative to the intersection points of the transversal with one of the parallel lines. So the points that I'm talking about in this picture are these 2 points right here. So corresponding angles would be in the same position relative to these 2 points. So upper right-hand corner would be 2 and 6, upper left-hand corner would be 1 and 5, lower left-hand corner would be 3 and 7, lower right-hand corner would be 4 and 8. Okay, so let's just do a quick sketch here. Okay, so corresponding angles would be these 2 angles. These are corresponding. These are corresponding, the red ones. And let's do, yes, you're right. And these 2 here would be corresponding angles as well. Okay, so there's 4 pairs of corresponding angles. There's only 2 pairs of alternate interior, and there's 2 pairs of alternate exterior angles. Okay, so let's just talk about this postulate here for a second. A postulate is something that we're going to accept to be true without proof. Okay, so in this case, if 2 parallel lines are cut by a transversal, then corresponding angles must be equal. Okay, so, all right, so I would know this, okay? You need to know that really well. You will be tested on this a bunch, okay? So what this is saying is that in this situation here, if these 2 lines are parallel, which they are now, all the corresponding angles are equal. So the 2 red angles are equal, the 2 blue angles are equal, the 2 orange angles are equal, and the 2 green angles are equal. Okay, that's our postulate. Theorem. If 2 parallel lines are cut by a transversal, then the alternate interior angles must be equal. Okay, so since this is a theorem, we have to prove this. Okay, so we have our 2-column proof here. Okay, remember it's called a 2-column proof because it's got 2 columns. This one is for statements over here. This one is for the justifications over here. Okay, I've got my given at the top here that line L is parallel to line M. And I want to prove I've got that next. I'm going to prove that angle 3 is equal to angle 6. So I'm going to prove that these two angles are equal. And I'm going to prove that angle 4 is equal to 5. Okay. And so here we go. My first statement is that I'm going to say angle 2 is equal to angle, oh wait, I gotta use my, sorry. Angle 2 is equal to angle 6, okay? Angle 2, we'll say it's congruent to angle 6, and I need a justification for that, and it is, we can abbreviate it like this: alternate interior angles equal, I'm sorry, that's not what we want to say. Parallel lines imply corresponding angles are equal. Okay, there's our first statement. Our first justification. Okay, now this is abbreviated. You can write it all out if you want to, but this is read: parallel lines imply corresponding angles are equal. Okay, so I've got angle 2 equal to angle 6. Now, the other thing I know is that angle 2 is equal to angle 3. Angle 2 is congruent to angle 3, and the reason I know that is vertical angles are equal, always. Okay, notice I've been marking up my picture here, and it shows me that these two angles are equal, they have the same mark. These two angles are equal, they have the same mark. Hey, guess what? These have the same mark, they must be equal. So we're going to go to angle 3 is congruent to angle 6, and that is the transitive property. Remember the transitive property from last time? Just to kind of refresh your memory, said if A is equal to B and B is equal to C, then A had to equal C. Okay, that's the transitive property. So if A is equal to B and B is equal to C, then A and C have to be equal. And we've proved this. Okay, now we would do exactly the same thing to show angle 4 is congruent to angle 5. So what we're going to write here is, instead of having to do this all over again, we're just going to say, similarly, for angle 4 to be congruent to angle 5. And we're done. QED, quad erat demonstratum. Okay. Take a few minutes, make sure you understand that, make sure you can wrap your head around that really well. Okay, the next theorem. If two parallel lines are cut by a transversal, then alternate exterior angles must be equal. So this is going to be very similar to the one that we did the last time. Okay, we're going to start out with, we've got line, we're given line L is parallel to line M. And this time we're going to prove angle 1 has to equal angle 8. And angle 2 has to be congruent to angle 7. So let's start out with, we know that angle 1 is congruent to angle 4. Okay, so angle 1 is congruent to angle 4. And that is because vertical angles are equal. Okay, now we can say that angle 4 is congruent to angle 8 because parallel lines imply corresponding angles are equal. Okay, because these are corresponding angles. And now we know that this one's equal to this one, this one's equal to this one, so these two must be equal. Angle 1 has to be congruent to angle 8. Okay, transitive property again. And then to show that we've shown this now, we have to show this. So we would say similarly for angle 2 congruent to angle 7. And we're done. So we can check that one off. We've proved everything we need to prove. Okay. All right. What is a converse of a statement? So if we have a statement, if P then Q, the converse is if Q then P. So what does that mean? Let's look at an example here. Write the converse of the statement. If it rains, then we will not go outside. Okay, so the converse of that would be if we do not go outside, then it rains. Okay, now here's the thing. This statement could be true, and this statement could be false. This statement could be true, and that statement could be false. The converse does not necessarily have to be the same, true or false, as the original statement. Okay? So, for example, we might have a policy that if it rains, then we just don't go outside. Okay? So, if it's raining outside, we don't go outside. That's true. Now, that doesn't mean that if we don't go outside, it's raining. Okay, it could be, maybe there's another reason why we couldn't go outside. Maybe we didn't have time to go outside that day or whatever. Okay, so you got to be really careful of that. Okay, write the converse of the alternate interior angle theorem. So the original alternate interior angle theorem says if two lines are parallel, then the alternate interior angles are equal. So the converse of that would be, I tell you what, take a minute, pause the video, write it down, then see if you get the same thing that I'm going to give you. Okay, the converse would be if alternate interior angles are equal, then the two lines must be parallel. Okay, now in this case, the original statement is true and the converse is true. They're both true. When that happens, that creates something called an if and only if statement. So you can say two lines are parallel if and only if the alternate interior angles are equal. What that means is both this statement and this statement are true. Okay, some of this, mathematicians are inherently lazy, so a lot of times you'll see notation, you'll see this, or you'll see this. Both of these mean if and only if. Okay? All right, so here I've got a little assignment for you. I'll see you guys tomorrow. Have a great day.